Good morning everyone. This is Zeba Anjum from St. Mary's School Lagina. This video is about computer applications with BlueJ of class 10th. We have already seen one previous video in which we were discussing about chapter number 1, that is your revision of class 9th syllabus. In this, we have already studied some of the topics of introduction to object-oriented programming concept, and we are going to continue with this video with the same. So at the very first, let us have a very quick revision of those which we have studied in the previous video. In the previous video, we have learned about some programming languages. Moreoverly, we have seen what are the procedural oriented programming languages and what are your object oriented programming languages. In POP languages, we have seen the emphasis or the focus is on your functions rather than your data value. But in object oriented programming concept, we have seen the focus is on data values rather than your functions. And that is what makes your object oriented programming the more secured and popular one. And your procedural oriented programming somehow less secured and somehow less popular one. Now, coming towards the principles of object-oriented programming, we are having mainly four principles over here: data abstraction, encapsulation, inheritance, and polymorphism. Now, let us see each of them one by one. First principle of object-oriented programming is your data abstraction. This term could be better understood with the help of an example. Consider you are driving a car. While driving a car, you came across certain number of things, like you came across brakes, you are having steering wheel, a window, etc. But some of the parts of your car are kept hidden, likewise your engine, your fuel, etc. And if you feel any difficulty while driving a car, then you directly visit to a mechanic. Why? Because only a mechanics know some details about your car, but not you. So this data abstraction means knowing only the essential details but hiding all the unnecessary details for you. This could be better understood with the help of one more example. Assume you are making a phone call. While making a phone call, you just dial a number, but in actual, we are unaware of actual transmission that is being taking place. So in this, we can see we are known by only the essential information, but regarding the background details, those are kept hidden from us. Now coming towards the formal definition of your data abstraction, it says it is defined as an act of representing essential features without knowing the background details. Coming towards your second principle of object oriented programming, that is your encapsulation. Encapsulation itself defines a word capsule, and we all know how a capsule looks like. Actually, two or more salts are being clustered together, and we take this capsule as a single unit. The same concept we will apply in your encapsulation. We all know about a class. Yes, we know a class contains mainly two things. First one, your data values and your member functions. If we combine both the two things, data values as well as your member functions, then actually it becomes a class. See this figure. In this figure, your data values and member functions are grouped together, or you can say these two things are wrapped together in a single unit, and that is known as your class. In this figure, we can see data values and member functions can communicate with each other. But what about some external function? If any of the external functions comes into role, then we can see the data values are not directly accessible to this external function, but you can access these data values through some member functions. Now going back to that example that we have seen in abstraction portion, we have taken the example of a car. Now again see over here in this diagram, clearly we can see that here are in the middle portion we are having some data values. Those are your speed, make, color, model, etc. Again we are having some member functions. Likewise start car we are having set color, get color, etc. And in this figure you can see the data values can only interact with your functions but not to your outside world. And regarding your member functions, they can communicate with the outside world as well as with your member functions. So with this example we can see these data values are kept hidden from the outside world, or if any external objects comes into play, then that external object will only communicate with your member function but not to your data values. Now this concept enforces one more concept of object oriented programming, that is your data hiding concept. Data hiding concept is very important in encapsulation, and that is how this concept is being applied. Now coming towards your formal definition of your data encapsulation, it is defined as wrapping up of data and functions of an object as a unit that can be used together in a specific operation. Moving towards your third principle of object oriented programming, that is your inheritance. Inheritance actually shows the relationship between two or more classes. Now consider one class. We are having shape as a class. Now you can see in this real world we are having different kinds of shape. Now let us take only two example of it. Let us say we are having two classes, 2D shapes and your 3D shape. Anyhow, we know that 2D shape is a subpart of shape. Again, 3D shape is also a subpart of shape. And if we divide this 2D shape into furthermore divisions, then we can see 2D shape can be divided into circle, square, rectangle, etc. But 3D shape can also be divided into cube, sphere, cuboid, etc. So with this example, what actually we mean to say is one class is being inheriting the property of another class. Now see, here comes the role of your base class and your derived class, or you can say a parent class and your child class. Now let us see only this portion of the figure where we have divided this shape into only two parts, 2D shape and 3D shapes. For only this portion of your figure, we can say that this shape is a base class and your 2D and 3D shapes are your derived class. Now coming towards only this portion of this figure where 2D shape is being divided into two portions, circles and square, we can say that 2D shape is a base class and circle or square are the derived class. Again coming towards this right portion of your figure where 3D shapes is being divided into cubes and sphere, we can say 3D shape is a base class, cube and sphere are actually your derived classes. So by this what we actually want to say is if you have written any line of code in shape class, then for 2D shape class you need not write these code. Why? Because these are being inherited. If you are inheriting this class, if you are inheriting this shape class by this 2D shape class, it means what? All the codes, all the principles or all the data values are being inherited in the derived class. So we can say that there is a removal of duplication. Duplicate code we need not write over here. Now here comes again the concept of reusability. Now here are certain advantages of reusability we are having. First one, minimizes the amount of duplicate code. Yes, we have seen over there in the shape class, if we are writing certain line of code, then for 2D shape class we need not write those line of code, and ultimately it makes our program easy and understandable. The third point is less memory space and time. Again it is pointing towards your first point because the duplication is being removed. That is why your line of code will be decreased, and if line of code will be decreased, then obviously your program will take less memory space and you will be taking less time for the program writing. The fourth program increases execution speed. See in this figure what we have seen, we are actually enforcing about your modularity portion over here. So if your modularity increases, then ultimately your execution speed will also be increases. Now coming towards again your third principle of object oriented programming, that is inheritance, let us see what is the basic definition of it. Inheritance is a property by which one class acquires some features from another class, and it obviously promotes your reusability. Coming towards the fourth principle of OOPS language, that is your polymorphism. Polymorphism is actually the most important principle of object-oriented programming. It is combined of two Greek words, that is poly and morphism, and each of them are having their different meanings. Poly means many and morphism means forms. So at a single term, polymorphism means one thing, many form. Now let us take one real life example to explain this principle. Consider you are having a phone. A phone is a single device, but we can use this phone for handling multiple operation. Likewise, with this phone you can make your call. With this phone you can access Google Map. You can also surf internet. You can get the support of your social media. You can play games, etc., etc. But anyhow, you are having only a single phone for accessing all these functions. Coming towards some coding part, consider you are having three variables of integer data type, and if you apply an addition operation between those two, then the output you will be getting is the addition of the two variables. Over here we are having a equals to 10, b equals to 20, then ultimately you will be getting 30 as an answer. Now if again we change only the data type of those variables, let us consider we have taken a string a equals to comp, b equals to ter, and if we are applying same operation, that is same addition operation, if we are applying over here, then the output will be the concatenation of these two. Now in this example you can see we are having only a single operator that is working on both the examples, but our output are different. That is what polymorphism means. We are having only one operation, and according to the situation it is taking many forms. Now, coming towards the definition of your polymorphism, polymorphism refers to the fact that you have multiple methods with the same name in the same class. Now, these are all about your four principles of object-oriented programming. In our next video, in the next video, we are going to see unit number 2, that is elementary concepts of objects and classes. Furthermore, we will be seeing what are the objects in details and what are the classes, some examples of both the things, and how these objects and classes are interrelated with each other. Now, regarding the unit number 1 exercise portion, I have created a blog that you can see over there, and I have also provided the link in the description below. In case you feel any difficulty, then please let me know. Thank you so much.